Okay, so student, very good evening. Today we are going to discuss about the image formed by convex lens when object is placed at different position in front of the lens. Okay, okay everyone.
Yes, sir.
Okay, sir.
Okay, so first condition. Okay, let object is placed at infinite distance. So when object is placed, just see, object is placed at infinite distance or infinity. Okay, infinity. So first we'll have to discuss the diagram. So here we have the lens. Okay, this is the principal axis. Okay, here we have the optical center. Then here we have the focus F. Here we have the center of curvature. Okay, likewise here we have F, and here we have the center of curvature for the other part of the lens. Okay, so as we know, when light rays are coming from the distance object, okay, they always travel parallel to the principal axis. Is it? Means light rays will travel parallel to principal axis like this. Is it or not? Is it?
Yes. Yeah.
And after refraction through focus, okay, like by the rule of refraction of light we have gone through in last class, when light rays incident on lens parallel to principal axis, and after refraction they passes through the principal focus. So light rays will passes from the focus like this. Okay, means these two rays are intersecting at the focus only. That means object is at infinite distance, so the image will form at the focus. Okay.
Sir, second focus, right? F2.
Yes, yes, yes. F2. Suppose it is F1 and it is C1, so it is F2 and it is C2. So yes, it is at focus on the positive axis. Okay.
Okay, sir.
So conditions: when object is placed at infinity, then image will form at F2 according to the diagram. Okay, and the size of image is the point image. The image is point image. Point image means highly diminished. And suppose if you will place screen over here, if you will place screen, so you can easily focus or project that image on a screen. Okay, so whatever the image you can focus or project on screen are called as beta real image. Okay, so this is another point, this is another point, and one more point here. The image is real, beta real. Okay, and if you will see here, okay, if you will observe clearly, the image will form inward beta, inward. Okay, so the image is real and inward. Okay, this point you have to remember. Okay, this is the way or direction of the propagation of light, like this. Understood? This is the
Yes,
screen. Screen. Okay, this is the convex lens. It is called as the biconvex lens, basically. Okay, so take a screenshot. This is the first screenshot for today.
Done.
Done, everyone?
yes, sir. Done.
Okay, let me check if somebody is in waiting room or what, because I'm not getting notification. Yes, Chanchal is there. Okay, so now second condition. Second condition. Okay, let object is placed beyond the first focus. So between infinite and focus, we'll let the object. So condition is when object is placed.
Is beyond 2f1.
Yes, when object is placed between infinity and focus. Okay, which focus? F1. We are taking F1 according to our diagrams. Okay, so let me draw. This is the convex lens. Okay, wait a second. Like this. This is the principal axis. Okay, here we have the F1. Here we have F2. Here we have C1. And here we have C2 and the infinite distance over here. Okay, so suppose this is the infinite distance and we are placing the object between infinite and the center of curvature. Okay, so see, it is just opposite of not focus, so we will write center of curvature beta here. So I'm writing center of curvature here. Because you know the distance from the center of curvature, okay, is just double from the focal length. Is it? That's why we used to take sometime 2f1. Okay, so center of curvature. Understood, everyone? So object is between
Yes, sir.
infinite and center of curvature. Over here in between. Okay, so one light ray will passes parallel to principal axis like this, and after refraction it will passes through the second focus like this over here. We are drawing one light ray from the pole. So one light ray will passes. One light ray will passes through from here and will intersect over here. So that intersection point will be the image. Okay, like this. So the image is forming between F2 and C2, means between focus and the center of curvature to other side of the lens. Okay, so when object is placed between infinity and center of curvature, then number one, then after then we have to write number one. Then image will form between what? Between
Between
F2.
the
Between
2f2
F,
and f2.
yes, F2 and C2 beta. To C2 you can write to F2 also.
Your voice is breaking, sir.
Voice is breaking still. Everyone?
No, sir.
Yes, sir, a little
It was
bit.
breaking.
Yes,
Okay.
sir.
Okay, probably, but I have no issue, internet issue. I do not have any. Okay, probably. Okay, so when object is placed between the center of curvature and infinite distance, then image will form between F2 and C2. That C2 is nothing but beta 2F2. Okay. Now, second, image will be the smaller than the object, so it is diminished. image is diminished. Diminished means smaller. Okay, and it is again, if you will place screen over here, okay, so you can project image on the screen, so it is real
It's real
image.
and inverted.
Yes, yes, not inverter, it is invert. Okay, Samar, image,
Yes, sir. Yeah. Real and inverted.
yes, image is image is real. Why it is called as real? Because you can project that image on screen. That's why it is called a bit of real. And invert. Invert means upright down, huh? Sorry, upside down. Invert means upside down and downside up. Okay? Understood, everyone?
Yes, sir.
Okay. So this is the second condition. Now we will discuss the third condition. Again, take a screenshot. Done, beta? Okay. So we will discuss the third position. Okay. Third position. When object is placed at center of curvature. When object is placed at center of curvature. Center of curvature. Center of curvature is nothing but 2f1. No? 2f1. Okay. So again, I'm going to draw the image over here. The diagram. So this is the convex lens. This is the principal axis. Here we have the pole. Here we have f1. Here we have c1. C1 is center of curvature. Here we have f2 and here we have c2. Okay, and you always remember the focal length and the radius. Okay, so radius is just double, it is also called as the radius of curvature is double than the focal length. So c2 can be considered as beta 2f2 and c1 can be considered as 2f1. Okay, everyone do reply.
Yes, sir. Yeah.
Okay.
Yeah. Good.
So object is placed at center of curvature over here like this. It is erect object. Okay. So one light ray again will passes parallel to principal axis and after refraction will passes through like this from the focus.
The image will be formed at C2, right?
Beta? No. The
Sir,
parallel line, yeah. If light ray incident on the lens parallel to principal axis will always pass it through the focus only, the f2. And one light ray will pass it through the pole beta, pole from here.
Yeah. But sir,
Okay?
the image will be formed at C2, right?
Yes, that we will take after the
Yeah.
intersection. Yes, see the intersection over here. Intersection of point is here, and it is just on the C2. Means it is on 2f2. We can say also. Okay, so what is the condition when object is placed at center of curvature? Okay, then number one, image is formed at C2 means center of curvature, or it is also called as 2f2. Okay. See, the image and object size will be the same. Okay. Second, the size of image is as same as object. Okay. Number 3. Image is, see, you can see it is invert, and if you will place screen over here, you will be able to project that image on a screen. Is it or not? Means it is real. Image is the nature of image. The nature of image is real and invert. Okay, everyone. Any doubt here?
No doubt, sir.
So now you are understanding, no, everyone properly.
Yeah.
Okay. So this is the third condition. Now we will discuss the fourth. Take a screenshot. This is the third screenshot for today. Done?
Yes, sir.
Okay. Let me
Yes,
check if somebody is in meeting room or what. No. Okay. Now fourth condition. Okay. Now we will place the object between center of curvature and focus. So when object is placed between center of curvature means beta it is C1, okay, or it is also called as 2f1. So I'm writing in bracket 10 number 1. So we have to draw first. We have to check whether the image is going to form.
The center of curvature and the second one, I think you have not mentioned.
Which one, beta?
Sir, here one object is placed between center of curvature and
Yes. Focus. Yes. And focus means f1. Okay, then number 1. We will check first. So again, I'm going to draw the diagram. This is the lens. This is the principal axis. Here we have the pole. Here we have the focus f1. Here we have the center of curvature C1, and here infinite distance. Here we have the f2, and here C2. C2 is also termed as 2f1, and C1 is termed as beta is 2f1. And we are placing the object between center of curvature means C1 and focus f1. So I'm placing the object over here like this. Okay.
yes, sir.
Okay. So let's draw the diagram. The ray one ray will passes parallel to principal axis, and after reflection will passes through the focus like this. And one ray will passes through the pole, and it passes without any reflection. Okay. So intersection point is over here. Oh, wait a second. Let me. Oh.
It would be. I think it would be beyond C, sir. So we must extend the line.
Oh. not beyond. So it is going to form between F2, it is F2 and C2. Yeah.
Sir, I think it's beyond C2, right? Because in if it is beyond C1, then it is formed between C2 and F2. If it is
Yes. Wait a bit. It is F2 and it is C2. Like this. Yes. So the intersecting over here. So image is like this. And here we have the infinite distance. Okay. So, then number one, image will form. The image will form between center of curvature C2 and between C2 and infinite distance. Okay, like here infinite, and here we have the center of curvature, it is C2, or instead of C2 we can write also 2F1, sorry 2F2, like this. They're the same. Okay, and infinity and infinity. Number two, see, as we can observe here, the size of image is greater than the object. Is it or not? The size of image is magnifying. Magnified. Okay, magnifying.
it's magnified or enlarged.
Yes, magnification means the enlargement.
Yes, sir. Same.
Yes. Magnified means enlarge. Okay, or we can say the greater also, larger in size. So I'm writing here in bracket, larger in size. Number three, nature. So image will be real because we can project on screen and it is inward beta. So the nature of image is real and inward. That's all. Okay, understood?
Yes, sir, understood.
Okay. Now take a screenshot. Everyone done?
Yes, sir.
Okay.
Done, sir.
Yes, sir. Right.
Now, I think the condition number 5. The position of object at F1 when object is placed at focus means F1. Okay, then so first we have to check. Suppose this is the lens. Here we have the principal axis. Here we have F1. Here we have C1. And again C1 is nothing but 2F1. Here we have the pole. Wait a second. Okay. Okay. So, it will make full screen. Okay. So object is placed. So here we have F2 and here we have C2. Okay. And object is placed beta at F1. Okay. So again, like one light ray will incident on the lens parallel to principal axis, and after a refraction, it will passes through the principal focus like this. Okay, over here. And another light ray will passes through the pole, and it passes without any deflection. Means
Yes,
these
it would
two
be.
lines, yes, these two lines will never intersect each other, but we are just considering they will intersect at infinite distance.
Infinity.
Yes, they will intersect at infinite, and there the very large image will form. Okay.
Yes.
We are just considering that it is hypothetical. So then,
Sir, so by this type of lens, we can produce a image of a very small object to a large object like the sun.
image, yes, we can, but the image will become blur because that image is going to form at very infinite distance.
Okay, sir.
Okay. So then number one. So the object, sorry, the image will form at infinite. Image will form at infinity or infinite distance, we can write also. Number two, the size is very large. Size of image is very large. Number three, again it is real and invert. The nature of image will be real because we can project on screen, and invert, I mean it is upside down. Understood everyone? The fifth
Yes, sir.
condition is
Understood.
also okay. Any doubt here? No, na? Now last condition. Now the last condition. I think it is sixth one, no? Yes,
Sir,
sixth condition.
in order to take a screenshot, can you please show?
Okay, yeah.
Okay.
Done? Done, na?
Yes, sir. Done. You can continue.
Now we will discuss the sixth condition. What will be the sixth condition? Now we have only one between the pole and the
Between
focus.
the pole and the focus.
Yes, when object is placed between focus, means F1, and the pole. So again, then dot. So I'm just writing number 1 point. So first we have to draw the diagram for that condition. So here we have the lens. Here we have the principal axis. Here we have the pole. Here we have the F1. Here we have C1, and again C1 is nothing but 2F1. Then here we have F2. Here we have C2. And object is placed between focus and the pole. Like this. So I'm just drawing one light ray. It is parallel to principal axis. Again, after refraction, it will pass it through the focus like this. Okay, and one light ray will again pass it through the pole like this. And if we will draw back side, like this, so they are going to intersect over here. So image will form over here, beta, on the same side of the image.
Same side of the object.
Object, yes. Okay, so image will form on same side of on the same side
As the object
of the lens as the object. Same side of the image will form on the same side of the lens as the object. Okay, and again, as we can see here, image is very large as compared to the object. So number two, yes. So image is very magnified, means very large. Okay, and see, if we will place screen, okay, so the image, see, light rays are as we can see here, we cannot place the screen here. If we will place the screen, then image will not going to form, because light ray will not going to fall on the object, is it? So we cannot project that image on a screen. That's why it is virtual. Okay, that's why it is virtual. Number two, the image. So number three, nature of image is virtual.
It's virtual and erect.
Yes, and it is erect. Erect means upright up and down, upside up and downside down as image. So it is virtual and erect. Okay, so this is the ray diagram for all the position in case of the convex lens. Take a screenshot for that. Sorry.
Okay.
So now we will discuss about the image formed by the concave lens, and we have only I think one diagram. Only one diagram is possible for that.
There are two, sir. We have two.
Two?
Yeah.
Okay. Okay. We'll check. So we have here the image formed by concave lens. Okay, when object is placed at different position in front of the lens. Okay. So number one, we will place object at infinite distance. Yes, for infinite distance we have the another one. Okay. So first condition, when object is placed at infinity. Okay. Then number 1, but we have to discuss that first. So I'm just drawing the concave lens. It becomes very curved one, so I'm taking another diagram. Okay, so this is the concave lens. Here we have the principal axis. Here we have the pole. Here we have the pole. Here we have the focus. Here we have center of curvature, and here the infinite. Again F1, C1. Here we have F2, and here C2, like this. Okay. So again, I'm suppose we are placing the object at infinite distance. So all the light ray will fall or will incident on the lens parallel to principal axis. Is it or not? Is it?
Yes, sir, it is.
Yes. So here we have the one light ray and another light ray I'm taking from here. Okay. So as we know, the image will form at focus only. Now we will first draw the ray diagram. See, when we know we have already gone through the laws of reflection or refraction of light by the lens. So whenever the light incident on the lens parallel to principal axis, they passes through the focus or they appears they are passing through the focus. So the light ray will passes from here like this. Okay, and if we will draw the back, it will seems like it is coming from the focus. Is it or not?
Yes, sir, it is.
Like this. So light ray will incident parallel to principal axis and it diverge like this. Okay, but if you will draw this light ray in back side, so it will appears like it is passing through the focus only. So image will form here beta at the focus. Okay.
Yes, it will be
Yes.
virtual
So,
direct also.
yes. Yes, it is again the forming on the same side, so it is virtual. We cannot project on the screen, and it is a point image, and it is if it is virtual and it is the erect one also. So let's discuss point here. An object is placed at infinite distance, then image will form at focus means on F1. Sorry. Number 2. The image is point image. The image is point image. Point image is very small. Number 3. Nature. The nature of image is virtual and
Direct.
erect. That's all. So this is the first condition for the concave lens. Okay. So take a screenshot beta first. We'll discuss the second one. And I think we have only one possible condition. Take a screenshot beta.
I think we have to another is any point in between.
Yes, in between
P
infinity. Yes, yes. Between pole and any distance between infinity. Okay, take a screenshot. Done.
Done, sir.
Okay.
Done, sir.
Second condition. Second one. when object is placed at any position between optical center. Every time we have taken the pole. No, it is optical center O beta.
Yeah, that's optical center or pole, anything it can be
Yes.
said.
Yes. So it is optical center. No? I have taken sometime pole, but it is not a pole. It is the optical center. Here, you take a right optical center. Pole in case of mirror. Okay.
Yes.
Yes. Okay. Between optical center at any position between optical center and infinity. Not at infinity, it is between optical center and infinity. Then,
Yes.
number 1. So first we have to draw the ray diagram. Like this. This is principal axis. Again, here we have the optical center O. Here we have F1. Here we have F2. Here we have infinite distance. Here, no, it is not F2. It is C1. And it is considered as 2F1. Now here we have F2.
There is no need for C1 or F1. It can be any point.
Yes, but we had to write because
those are the points of principal.
Yes. Okay. So suppose at any distance we can take. So I'm taking over here. Okay. And let this point is Q. This point is Q. In front or in between infinite and optical center. You can take any point Q anywhere. Okay. So one light ray will always passes parallel to principal axis, and after refraction will passes through the focus like this.
No sir, it will diverge, sir. You have converted.
Oh, yes. Sorry. So like this. Okay, and if you will draw that line back side, then it will pass it through the focus. Okay. Now next light ray will pass it through the optical center like this. Like this. Okay, and the intersection point, that one, here image will form beta. So at all the position, image will always form between optical center and F1. Okay.
Yes.
So when object is placed at any position between optical center and infinite, then image will form between
optical center and F1.
Optical center, yes. Optical center and F1. Number 2. See, the image always be the small as compared to the object. Yeah, it is diminished. It is smaller than the object. So the size of image is diminished. Means smaller. Okay. Number 3. See,
it will
the
be
image is
virtual and
erect.
direct.
Yes, erect and virtual. The nature of nature of image is virtual and erect. That's all. So the image will form for all the position except infinite. Now, all position between infinite and optical center, the image will always form between focus and optical center.
Yes.
Okay, everyone?
Yes.
Everyone do reply.
Yes, sir.